Okay, so now the really challenging topic for today is U-substitution. But I want to first explain U-substitution without using U-substitution. I know some of you already took AP Calculus and you know U-substitution already, but for the time being, I want you to pretend that you don't know how to do U-substitution. You only know how to differentiate, so that the result is that you'll get a better understanding of how U-substitution works. Okay. All right, so we're going to start with sine of x squared prime. Okay, find the derivative and write the corresponding antiderivative statement. That's the question. What's the answer? Cosine x squared times 2x. We usually write down 2x before cosine because this way you need this parenthesis or else it doesn't make sense. Here you can get away with not having the parenthesis because 2x is in front, so people write it like this. Okay. All right. What's the corresponding integral statement? 2x cosine of x squared dx is sine x squared plus c. Okay. Now, I want you to think about this result and notice something strange about it. So I can see where the sine came from. It came from cosine, right? Cosine antiderivative, because if you differentiate sine, you get cosine. Therefore, the antiderivative of cosine must be sine. I can see where this x squared came from is the same x squared, right? But then what happened to this 2x? Just went away, right? So that's the thing that I want you to think about. Why did 2x go away? What happened to 2x? Well, to answer that, you have to look at what happened in the derivative side, right? Why don't we see 2x in the result of the integral? Can anyone explain?
Because when we did the chain rule, that's when we brought in the 2x because it was the derivative of x. On
X squared. It was the derivative of x squared. Yes, yes. So 2x was created by the chain rule, and therefore if you undo the chain rule, it's going to go away.
So it's going to be a difference.
Does that make sense? 2x was created by the chain rule, so since integration is the undoing of the differentiation, when you undo the chain rule, it also takes away that anything that was created by the chain rule. Okay. So there's a word I like to use. I usually call this as the artifact of the chain rule. And because these are artifacts of the chain rule that just suddenly appeared, when you undo the chain rule, they disappear. That's the idea. Okay? All right, so here's another challenge. Now this time, I am not going to start with the derivative. I'll just write down a problem of integration, but your challenge is to figure out which one is the artifact of the chain rule and guess what the antiderivative is. Okay, so example 1, integral of 3x squared e to the x cubed dx. Which one is the artifact of the chain rule?
3x squared.
It's this one, right? Why do you think so?
Because the derivative of x cubed is 3x squared.
Yes, exactly. If you look at this x cubed, which is nested inside the exponential function, if you differentiate x cubed, what do you get? You get 3x squared. Right? So this must have been created by the chain rule. So it's like you're playing detective. You go to the crime scene and you have to think about what happened, which one appeared because of what, right? And you look at this and say, oh, this 3x squared there was created when this got differentiated. So this is the artifact of the chain rule. What does that mean in the answer of the antiderivative?
It's going to be different.
It will disappear. Yeah. So the artifact will disappear when you integrate. Okay? So that goes away, and what do you think the answer must be? E to the x cubed plus c. Now, then you can do a check. Now let's do a check. How do you check the integral? Actually, this is a very important skill to get high scores on your exam 1. Yeah. When you write your answer, you want to check whether you got it right by differentiating your answer. It better match with the question, right? So let's differentiate. Again, it's the chain rule. Just think about x cubed is some kind of a Chinese character, like some strange character, okay? A single number. So e to the big X. That's how you mentally think of it. Then what's the derivative of e to the x? E to the x. So what do you write? E to the x cubed. But then the chain rule says what? You multiply by whatever you treat it as a single character, you differentiate that. That's chain rule, right? What do you get? 3x squared. Indeed, it matches. So we did get the correct answer. Okay. And as you can see, this 3x squared was really just an artifact of the chain rule. Good? All right. Let's do another one. Here it's slightly more challenging. 2x times x squared plus 1 to the 10th power dx. How about this one?
What's the artifact?
Yeah, which one's the artifact? That's first.
Judging from the looks of it, I would think that it's 2x.
2x, right?
Probably
2x.
because there was a product rule in there. Or,
Yeah,
no, oh wait, it's artifact of the
there's-
chain
yeah,
rule,
no,
so
no,
it would be
yeah,
chain rule.
Yeah, so this 2x must have been created when you differentiated x squared plus 1. Do you agree? Okay. X squared plus 1, when you differentiate, you get 2x. And therefore, this is just the artifact of the chain. Okay. All right. Next, then this is really artifact, and you're treating x squared plus 1 like a letter. Okay. And that's where this idea of U substitution starts appearing. Okay. So what you want to think of it is like, think of this one as if it looks like U to the 10th power. Now, if you integrated u to the 10th power, what would you get? The integral of u to the 10th du would be, it's the power rule, right? What do you do?
10 u to the 9?
Yeah. No, add 1. Add 1.
Oh, yeah.
Okay, so add 1 to the exponent. What do you put here?
11.
11. And what do you put in front?
1 over 11.
The reciprocal. Okay. And then plus c, right? Yeah. But instead of this u, what's taking the role of u here?
X squared plus
X squared plus 1 is taking the role of u. Right? So what you put is, you put x squared plus 1 to the 11th power, 1 over 11 plus c, and I don't care about 2x because that's going to be created by the chain rule. This is an artifact of the chain rule. Now let's do a check whether that's correct. Check. Prime, 11 comes down, right? Subtract 1, that's how you differentiate, right? 10. What do you do afterwards? Yeah, x squared plus 1 was the inside function. So you take the derivative of the inside function. And this creates 2x. 11 over 11 is just 1. So you get 2x times x squared plus 1 to the 10th power. Okay, so from these examples, now I'm ready to talk about the U substitution. The second example should have made you nervous a little bit because, like, it's hard to think about this, right? And what U-substitution is, it tries to make this more streamlined, okay, and less confusing. So let me talk about U-substitution. And let me start with the very first one. Here's how you do the U-substitution approach to example 1. So I'll redo example 1. And I start out by picking a U. And I'll pick U equals to x cubed. Now, why did I choose U to be 3x squared? Why does it have to be x cubed? Well, because 3x squared is the artifact of the chain rule that's going to go away. It's really this inside function that we want to set as U. That's how U substitution works. So even if you didn't like what I did over here, it's still necessary for you to see something and judge for yourselves, oh, this should be like the U and the other one is like the artifact. If you develop that intuition when you see an integral, then U substitution becomes more straightforward. But however, it doesn't always work. Sometimes even if you have some ideas, sometimes you may have to do trial and error. Okay, so in some cases it's an easy question what U should be, but in some cases it's hard and you may have to do it several tries. You try, let's say U is this one and it doesn't work, then you say U is the other one and it works. It may happen that way, but in a lot of cases you can just make a judgment, right? Okay, so once you have that, then what you want to do is, so I would call this as step 1. Okay, set U as something. Okay? And then step 2, you differentiate, and you want to use the Leibniz notation. Rather than saying U prime, you want to say du over dx, because that's actually pretty important. What is the derivative of the right side?
3x squared.
3x squared. And then step 3, what you want to do is solve for dx. And how do you solve? Well, you know, in calculus 1, you've never thought about du over dx as quotient of two entities, because we try not to speak about du and dx as some physically meaningful thing, but I think I vaguely explained last time that du and dx, these are called infinitesimal things, which are very, very close to 0, so it doesn't have any physical meaning by themselves, but if you take ratios, they have a finite value, they have meaning. And then also, when you integrate like this is a summation of these things, right? So because this is a very, very small quantity, and this is a finite quantity times a very small quantity is still very small. However, if you integrate them, if you add them up, it gives you some physically meaningful value, okay? One change, I guess, when you go from a differential calculus to integral calculus is that you start to think about the meaning of these infinitesimals, okay? So we're going to treat du and dx as like separate things. They have meanings. And I'm going to multiply dx both sides first, because I want to solve for dx. And here's what you get. You get du equals to 3x squared times dx. And then I can divide 3x squared both sides, and you get 1 over 3x squared times du equals to dx. So 3 steps. And once you're done with these 3 steps, then you can say, you can just change everything in this interval. So let's try this. Well, right now 3x squared has nothing to exchange for, so just leave it there. But this x cubed, what can we write instead? U, okay? This dx, what can we write instead? Dx is 1 over 3x squared du, right? So you write down 1 over 3x squared du. And what do you see? You see that 3x squared cancels, and it's very important that before you do any integral, you have to make sure that all the x's are gone. Okay? A failed U substitution is when you did all the changes and cancellations and you still have some x's left over, then that's a failed U substitution. Okay, you may have to do something additional, or you may have to choose a completely different u. Okay? But you can't do the integral if there's still some x's in your expression. You shouldn't do that. Okay. So we have integral of e to the u du. We integrate this, and that's easy, right? That's e to the u plus c. And since u is x cubed, you go back and write down e to the x cubed plus c. A common mistake is people feel some sense of achievement when they write this and like, oh, that's the answer, and they stop right here. That's a pity because it's like a runner like in a competition for 100 meters and they stop at 99 meters thinking they won. Have you seen that video, like celebrating too early? You have two runners and the one guy thinks that he won, and so he's like raising his hand, and the other guy that was right behind him just passes by. So he gets the silver, not the gold. All right, but anyways, don't stop here, okay? Just always go finish up by going back to your x because the original question was given by x. All right, so that's good. Let's try to do the second one. Actually, I'll give you some time to think about the second one. Try to do these, follow these 3 steps. To get the exact same answer as this one. Okay? And when I give you time to do the work, you should try it. But if you get stuck, you should also ask around if you have no idea. And also, if you're done with your work, please compare your answer to the person sitting next to you.
He's wanting us to do the second one. We did the last one we did was the first one that he brought up. The 2x times x squared.
Whatever you think is the inside function becomes u. What's the inside function? It's x squared plus 1.
Yes.
And then follow those 3 steps. Awesome. X squared plus 1 should be your u. U is not x squared, u has to be x squared plus 1. 2x, yeah. And that's going to cancel the 2x in front. Did you solve for dx?
Yeah.
Oh, that's good. That's good.
Yeah.
That's perfect. Yeah? Oh, you want to put x squared plus 1. That should be it. It's the same thing. It's because derivative is 0. That's still true, right? So now you can say, no, that's not true. The derivative goes away if you differentiate. Yeah, just replace this x squared plus 1 by u, and dx is replaced by whatever you have here. Are you stuck here? No, we're still integrating u to the 10th power du, right? What's the antiderivative of u to the 10th power?
Is this this would
No, that's good. Yeah, no, but your u is x squared plus 1, so you have to go back to x squared plus 1. Right? U is x squared plus 1. There is no integral anymore, and you forgot plus c. Minus 1 point. Forgot plus 1. Plus c. Right, and the 2x cancels, right? Isn't that right? If you differentiate, one goes away.
Okay.
That goes away.
And this will cancel out on this side.
What's the joke?
So it's 1 over 2x times d.
Oh. What do you?
Oh, no. See, this has to be replaced with this, right?
Why are you teaching?
We did the integral before here.
That was a bullet train moment, yeah.
Yeah.
You better do the tags, like, why are you give you the difference of this thing?
Whose antiderivative is
That is just beyond foul. Why?
Well, C. Plus C, minus 1 point. Okay, good. You got full credit, right? Yeah, that's the correct answer. You did Okay, very good. Some of you struggled in the beginning, but then as you did it, you figured it out. Now I saw as I was out walking around, the common mistake being that choosing u as just x squared. U has to be x squared plus 1. And again, you can ask why. Why is it x squared? Why is it x squared plus 1? Why can't it be x squared or why can't it be 2x? One answer is, well, trial and error. You try one way and if it's not going to work, the only one that works will be x squared plus 1. But a better answer is that when you see this, this really looks like some chain rule is applied. Okay? Yeah. So maybe you're at the crime scene and something is screaming at you saying, chain rule was here.
You like this calling card.
Like blood dripping or something. and you know immediately that, oh, there's like chain rule in this scene, and this has to be the inside function, and that's the ultimate. Okay? And once you get that, then it's easy to see which one is the u. Okay? So u is x squared plus 1, and the du over dx would be 2x. And if you solve this by multiplying by dx and dividing by 2x on this side, you get 1 over 2x du equals the dx, right? And we have everything necessary to change this into an integration with respect to u. And it works like this. 2x, you don't do anything. U is the entire thing, x squared plus 1. So this to the 10th power is like u to the 10th power. And then dx is 1 over 2x du, where 2x and 2x cancels, and you have an integral u to the 10th power du. And this is just a matter of simple antiderivative using the power rule. Add 1 to the exponent. Put the reciprocal in front. Another common mistake, even after screaming so many times, plus c. 3 people in this room managed to forget that, okay, and didn't put that, okay. So make sure you don't make the mistake, and I saw one person who forgot to replace the u by x squared plus 1. So that's the final.